Hello everyone. Today we're looking at solving 2 and sometimes 3-step algebraic equations, and we're also looking at algebraic equations that use the distributive property. So, to start, the order of operations when evaluating expressions is bedmass. When solving algebraic equations, it is generally helpful to undo operations used when evaluating expressions. Bedmass spelled backwards is samdeb. So that is not a hard and fast rule, but it is a good rule of thumb to use on many of the equations that we'll be looking at this year. We need to be a little bit flexible with our strategies, so practice makes perfect, right? Next, every step of the way we should work toward getting the variable upstairs and on its own. So in other words, into the numerator and on its own, using opposite or inverse operations. What we do is we group like terms first if we can. So like for this one, 3x minus 12 minus 5x, we can group the 3x and the minus 5x together to make negative 2x on the left. So the opposite of addition is subtraction, the opposite of multiplication is division, and the opposite of subtraction is addition, and division versus multiplication. So let's have a look at a few examples. So here we have 3x plus 8 equals 17, represented on the right with this scale. So we have 3 x's, and we have 8 blue circles on the left, and we have green circles. We have 17 green circles on the right. So what we can do to solve this using our model is I can remove 8 from the left, but I can't just do that because then the right side will weigh down significantly. So I need to remove 8 from the right as well. So now we have 3x on the left and 2, 4, 6, 8, 9 green circles remaining on the right side. So now it remains just to split these into 3 equal groups. So I need to make 3 equal groups with the remaining green circles. So each gets 3. So one of these x's is worth 3 green circles. Now if we're to do that symbolically, we basically replicate the same procedure. Subtract 8 from both sides, so that's like what we did here. Subtract 8 and subtract 8. 8 minus itself on the left is 0, so we're left with 3x. And 17 minus 8 on the right is worth 9. And last, the opposite of multiplying by 3 is dividing by 3. We want to get x on its own. 3 divided by itself on the left is 1. And 9 divided by 3 is 3. So we get x equals 3. Consistent with what we got with the model. Moving on to another example, we have 3x minus 7 minus 5x equals negative 11. So here we've got 3x minus 5x there, minus 7, and minus 11. So we can start probably by, we can start a number of ways, but I can start by removing 7 there. And I can remove 7 from the right side as well. So there's 6 I can remove, and I need to remove a 7th. So now I have 4 red circles left on the right. Now each of these pairs add to 0, so that's gone. 0, that's simplified. Those 2 are gone because they add to 0 as well. And I can remove those 2 as well because they add to 0. So what remains? I have 2 red x's, and if I make these into 2 equal groups, I can see that one of these is worth negative 2. So in other words, x is positive 2. So 1 positive x equals positive 2. Now, if I were to do that symbolically, what I can do to start is combine the 3x and the negative 5x. 3 minus 5 is negative 2, so I have negative 2x. And then I have minus 7 and minus minus 11 remains on the right. So next we can get rid of this negative 7. So the opposite of subtracting 7 is adding 7. I do that to both sides. 7 minus itself on the right, sorry, the left is 0. Negative 2x remains. Negative 11 plus 7 is negative 4. And now what I need to do is get rid of this negative 2. So currently it's negative 2 times x. So the opposite of multiplying x by negative 2 is dividing by negative 2. So I need to do that to both sides. And negative 2 divided by itself on the left is 1. So what remains is just an x. And negative 4 divided by negative 2. Negative divided by a negative is a positive. We get x equals 2, which is consistent with our result with the model. Okay. Next one. We've got y over 3 minus 3 equals negative 7. So using our polynomial tile sort of method, one full filled in rectangle like that would be worth 1x, but we only have 1 out of 3 of these regions filled in. So this represents 1/3 of x, or I guess in this case it's a y. We've got a negative 3 there and a negative 7 there. So if I were to solve this using the model, what I can do is remove 3 from that side, and I can remove 3 from this side if it'll let me. Let's try that again. I will just cross them out. How about that? Yeah. So I have 4 remaining on the right. So 1/3 represents 4. So if I were to fill this in, I'd get another 4. So 4 more of those. And if I were to fill in that one, I would get another 4 on top of that. So 1, 2, 3, 4. So my answer should be, right, that. So now we got a full picture. Y is worth 4, 8, 12 negatives. So hopefully that worked out. Let's see what the procedure is symbolically. So in this case I'm going to be adding 3 to both sides. So the opposite of subtracting 3 is adding 3. 3 minus itself on the left is 0. So I'm left with y over 3 on the right, sorry, the left. And negative 7 divided by 3, sorry, negative 7 plus 3 is negative 4. And now the opposite of dividing by 3 is multiplying by 3. So like 3 over 1. We got to do that to both sides. 4 over 1. 3 divided by itself is 1. So I'm left with y on the left. And negative 4 times 3, negative 12, which is consistent with what we found using the model. Alright, moving on to the next page. One of these full rectangles, if all of these were filled in, would be worth 1x. However, at the moment, we only have 2 out of 6. So ultimately, I want to get that red rectangle on its own with nothing else, okay, and then I can figure out what 1x is worth. So I'd like to get rid of these 3 squares from the left. In order for me to do that, I can add 0 pairs. So 1 yellow and 1 red makes 0. Okay, I can do that and that. But I can't just add 3 red squares on the left for free. I need to add 3 on the right as well. right? So now that adds to 0, that adds to 0, and that adds to 0. So I can just get rid of those. I'll clear those out of the way. And now I have 2 out of 6x is equal to 3. So negative 2 out of 6x is worth 1, 2, 3 negatives. So if 2 of these is worth 3 over here, if I did another 2, that would be worth another 3, like that. So that's good. And then if I had another 2 out of 6 of this x, I would add another 3 over here. So it should be the case that negative x is worth negative 9, right? Count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. And therefore x is 9. So 1x is worth 9. So let's see what the model, or sorry, the equation gives us. Subtract 3 from both sides. 3 minus itself on the left is 0. Negative 2 out of 6x remains on the left equals negative 3. Now I can, so if you like, you can rewrite this negative 2 over 6x like this. So negative 2x over 6, if that makes it any better for you. I'm going to get rid of this 6 first. It doesn't really matter. I could get rid of the negative 2 first, but we'll go for the negative 6 first. The opposite of dividing by 6 is multiplying by 6, so I need to do that to both sides. 6 divided by itself on the left is 1. So I have negative 2x remaining on the left, and negative 3 times 6 is negative 18. And now I need to get rid of this negative 2. Negative 2 times x. So I need to do the opposite of multiplying by negative 2. I divide by negative 2. Divide by negative 2. Negative 2 divided by itself is 1. So I have x equals, and negative 18 divided by negative 2 is positive 9. Alright, let's work through a few more examples. So we'll just stick with symbolically. So you can construct a model if you like. You can draw a set of scales, but I'm just going to stick with symbols because it's a little more efficient and quick. So this, I want to get q entirely on its own, so I'm going to get rid of the 3. Negative 3 plus 3 is 0. So I have 6q remaining on the left, and 1 plus 3 on the right is 4. Now I need to get rid of the 6. The opposite of multiplying by 6. Dividing by 6, I do that to both sides. 6 divided by itself is 1, so q remains, and 4 over 6 reduces to 2/3. That's the final answer for q. Okay, next, I need to get t on its own. So working through SAM/DEB, right, good rule of thumb, we add 12 to both sides. 12 minus itself is 0. So we have negative 9t remaining on the left, and negative 7 plus 12 is 5, positive 5. And we're closer, right? I got t nearly on its own. I need to get rid of this negative 9. It's currently multiplying the t. If I divide both sides by negative 9, negative 9 divided by itself is 1. So we have t is equal to 5 over negative 9. Now I could rewrite that as negative 5 over 9, or equivalently negative 5 over 9. These are all equivalent. It is generally more common to see it written in either this form or this form. This one's a little bit strange to see, but it's still fine, good enough. On to C. I want to get B on its own, so working through SAM/DEB, I'm going to do the subtractions and additions first. So in order for me to get rid of the 12, the opposite of adding 12 is subtracting 12. I need to do that to both sides to maintain the balance. 12 minus itself is 0. I have negative 1/4 b that remains on the left, and negative 8 subtract 12 is negative 20. Okay, next I can get rid of the 4, if you like. The opposite of dividing by 4 is multiplying by 4, so multiply 4 both sides. 4 divided by itself is 1. What remains on the left is negative 1b, or just negative b. Negative 20 times 4 is negative 80. And if I divide both sides by negative 1, divide negative 1. Negative 1 divided by itself, right, is just positive 1. And negative 80 divided by negative 1 is positive 80. So b is positive 80. Okay, last one on this page. We want to get x on its own. So SAMDEB, add 9 to both sides. Negative 9 plus 9 is 0. Negative 3 plus 9 is 6. We've got 7/8 on the right, x. So if you're comfortable with this, we can do this in one step. So 6 equals 7/8 x. Now, you could, if you like, multiply both sides by 8 first, and then divide both sides by 7. That works. Or you can do sort of the opposite of multiplying by 7 over 8, which is multiplying by 8 over 7. So 8 over 7 times 6 over 1. So 7 over 8 times 8 over 7 is just 1. We're left with x on the right. 6 times 8 is 48. 7 times 1 is 7. So we get 48 over 7. 7 fits into 48 6 times cleanly with a remainder of 6. And the denominator is still 7. So as a mixed fraction, that's fine. As an improper, we could write it as 48 over 7. Alright, now we're going to move on to a few questions involving the distributive property. So just to recap, remember, every step of the way we should work toward getting the variable upstairs, so in the numerator and on its own, using opposite operations. It is generally helpful to do any simplifications first to each side, if you can, before you proceed to solve. In the problems that follow, the variable may be buried inside a set of brackets, so we should simplify things first before we continue. And you may even notice a more efficient route to solve these equations as you get more comfortable solving them. So, again, a helpful rule of thumb after you've simplified everything on each side is to work through SAMDEB. So it is not like a commandment that you should use that sort of every time. Like, it's not something that's always going to be the best approach. So we need to be a little bit flexible and choose sometimes something that might work quicker. So hopefully we'll see some ways to speed things up a bit in that way. Alright, so this first example, we're going to solve 3 times x plus 4 in brackets equals 18. So represented using a model, we have 3 sets of x plus 4 equals 18. So I have 18 here on the right. Now, this 3, right, this 3 times this stuff, is instructing me to replicate the stuff in that blue box 3 times. So I have 3 lots of x plus 4. That's what that whole instruction here is telling you to do. So now I have 3x, count them, 1, 2, 3, and I have 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 12 green circles now on the right instead of the original 4. Okay, alright, so now we need to solve it. So now we just approach the problem as we always have. We've taken care of that. I can remove 4. Okay, it's going to be a bit tricky here. I'll just maybe cross them out. So remove those, and remove those. So 12 total were removed. So we need to do the same on the right. So there's 4, there's 8, there's 12. I'll remove that. And now I have 1, 2, 3, 4, 5, 6 that remain. So 6 needs to be spread equally among these 3 x's on the left. So I need to make 3 equal groups. And if I make 3 equal groups shared among these 3 x's, I see 1 x is worth 2. So x should be 2. So let's see how that looks using the inverse operations and whatnot. So what we can do is 3 times x and 3 times 4, a lot like we did in the polynomial unit on the last unit. So we have 3x plus 12 equals 18. And now it's just, business as usual. We want to get x on its own, so it would be helpful to get rid of that 12. I subtract 12. Okay, maybe I won't write that over bar just so that we don't accidentally divide. Subtract 12, subtract 12. 12 minus itself is 0. So we have 3x remaining on the left, and 18 minus 12 is 6. Now I need to get rid of the 3, so 3 times x. The opposite of multiplying by 3, dividing by 3, divide both sides by 3. 3 divided by itself is 1, so an x remains, and we have x equals 2, which is consistent with what we did with the model. Okay, next question. Negative 12 equals 4 times x minus 8. So again, we have this instruction to replicate the stuff on the right side. So we need to replicate x minus 8 4 times. So once, we need 4 equal groups of x minus 8. So that's what we did. We replicated it. Now we have 4x minus 32 on the right. I have 32 red circles now. Okay. It would be helpful if I could remove, a bunch of stuff. What's going to work here? So I think our model might not be the greatest for this situation, but we'll see how it works. Okay, I guess I gotta try that. Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8. We got 12 on the right, or sorry, the left, and then, so if I remove 12 from both sides, I'll just do that and that. So just clear those out of the way. So now I have something here. So we're kind of pushing our model a little bit. What I can do now is I want to get the x's on its own, so I need to get rid of these red circles on the right. So in order for me to get rid of the red circles, I can add 0 pairs. So if I add 4 green circles there, okay, let's see if we can do, so add a green circle for each of the red circles. Okay, so that everything sort of, keep forgetting. Okay, so we've got 1 green circle for every red circle, right? So they all add to 0, 0, 0, 0, and so on. Those all add to 0. I think I added 1 too many. I don't need those anymore. So I just need 1 green circle for every red circle, as I do here and there, so that all adds to 0. Okay, I also need to have the same number of green circles on the left. So I need to add the equivalent number of green circles. So I added 1, let's see, I added 1, 2, 3, 4, 5 sets of 4, so I should add 5 sets of 4 to the left as well. 4 and 5. So I now have 20 green circles on the left, and I've got 4 x's remaining on the right. So each x should count for 5, hopefully. So let's see if we did that correct. We need to distribute the 4 in here. We get 4x minus 32 equals negative 12. I want to get x on its own. I need to add 32 to both sides. 32 minus itself is 0. 4x. And negative 12 plus 32 is 20. I need to get rid of the 4 here. Divide both sides by 4. 4 divided by 4 is 1. And 20 divided by 4 on the left is 5. So x is equal to 5. Alright, moving on to the back. Next page, we've got 4 times 3x minus 5 equals negative 16. We're going to leave the models behind. By all means, though, if you want to continue using the model, please do. You can draw a set of scales to represent that question. But I'm just going to distribute the 4 into each thing. So I've got 4 times 3x, which is 12x, and 4 times negative 5, negative 20, and negative 16 on the right. I need to get rid of the 20. I need to work to get x on its own. 20 minus itself is 0. So now I have 12x, and negative 16 plus 20 is positive 4. I need to get rid of the 12, divide both sides by 12. 4 divided by 12 is a fraction. 4 over 12 reduces to 1/3. So x is 1/3. Okay, next one, negative 2 needs to distribute, so I have 2 lots, negative 2 lots of x minus 1.6, which would be negative 2x plus 3.2 equals negative 0.4. I need to work to get x on its own, so subtract 3.2 from both sides. 3.2 minus itself is 0. And I have negative 2x equals negative 3.6. And last thing I need to do is divide both sides by negative 2. Negative 2 divided by itself is 1. And negative 3.6 divided by negative 2 is 1.8. Okay, a few applications, not necessarily using the distributive property. So 18% of a number is 34.56. We're going to let a number equal x. So 18% of a number. If I want to take a percentage of a number, I multiply the number by the percent as a decimal. So 18% as a decimal, we take 18, divide by 100 is 0.18. So we got to go 0.18 of x. So 0.18 times x is equal to 34.56. That's another key word there, is. That's cueing you to use an equals sign. So now we need to determine the number. We just need to get rid of the 0.18. So if I divide both sides of this equation by 0.18, so just imagine that continues, divided by 0.18. 0.18 divided by itself is 1, so x remains on the left, and 34.56 divided by 0.18 is 192. So 18% of 192 gives us 34.56, which you can confirm, so probably a good idea to check. Check that 0.18 times 192 is equal to 34.56. Okay, next, Daryl gets paid $500 per week plus 10% commission on his sales. He earned $825 last week. So we want to write an equation that can be used to find out what his sales were. So his sales is the thing that we need to find. We'll call that X. So if we're making 10% on his sales, we're doing 10% of X. That's how I find 10% of his sales, which is represented by X. And on top of that, he gets paid $500 per week. So we add $500. And he earned $825 last week. So assuming he made no sales, right? Like if X was 0, he would just make his base rate of $500. So 500 plus whatever 10% of something is going to give us 825. So I need this something here to be 325 because 500 plus 325 is 825. So I could even simplify this further. I could say 0.10x is equal to 325. So that's an option. And then I could solve for x. X works out to be 3250 because I just divide both sides by 0.10. Now, if you didn't see that shortcut, what we can do is just approach it the normal way. Get rid of the 500 from both sides. 500. So now we have 0.10x equals 325, which was exactly the equation that we just solved. Divide both sides by 0.10. 0.10 divided by itself on the left is 1, so we have x remaining, and we get 3250. So we made 3250 in sales. Okay, last question we'll go through. Will is making a large bowl of fruit punch. He mixes 7 bottles each of soda water and concentrated juice. Each bottle of juice concentrate is 250 mils in volume. Determine the volume of 1 bottle of soda if Will filled 7,000 mils with the mixture. So determine the volume of 1 bottle of soda. That's the thing we need to figure out, so we'll call that X. He mixed 7 bottles of soda plus 7 bottles of juice concentrate, which we know, which is given to us, is 250 mils. And the 7 bottles of soda combined with the 7 bottles of juice concentrate gives us 7,000 mils. So now we have an equation and we just need to solve for x. So we need to get x on its own. So we can simplify this a little bit. So we can actually do this multiplication. 7 by 250 gives us 1750. And that's still equal to 7,000. So 7x plus 1750 equals 7,000. And now just get x on its own. Subtract 1750 from both sides. 1750. 7x remains on the left. 7,000 minus 1750 is 5250. And to get rid of the 7, you just divide both sides by 7. 7 divided by itself on the left is 1. So we have x remaining. And 5250 divided by 7 should be 750. So 750 mils. So 1 bottle of soda is 750 mils. Okay, so that brings us to your assignment. Please do those questions. I'll be checking that next class, and I'll see you later.